All right. Hello, everyone. We are Galveston Group 2 from CAM 117. My name is Abar Rahman, and joining me today is Nicholas, Guillermo, Andrew, and Daniel. Our project is named Corrosion Prevention in Marine Infrastructure. In this presentation, we'll connect our Galveston boat trip observations with the chemistry and engineering behind corrosion. We'll also explain why understanding corrosion is essential for safety, reliability, and the safety and the lifespan of marine structures. Now I'll begin by explaining why does corrosion prevention matters. Corrosion is one of the most costly and dangerous issues in marine environments. Seawater contains electrolytes like chlorine ions, which drive electrochemical reactions that weaken metals over time. Without prevention, structural materials lose strength, equipment fails faster, and safety risks increase dramatically. As we saw throughout Galveston, corrosion doesn't just affect ships, it affects docks, channels, pilings, and even cruise terminals. Okay. Nicholas will now explain how the coastal environment and the chemistry accelerate this process.
Thanks, Abrar. I'm Nicholas, and here's the chemistry behind what we saw. In coastal environments, there's high humidity, constant moisture, and salt spray, which create the perfect conditions for corrosion. Pollutants such as sulfur dioxide form acidic films that attack protective coatings, and once the oxide layer is damaged, dissolved oxygen and chloride ions can rapidly oxidize the exposed metal. This means that even structures designed for marine use can degrade quickly if not protected properly. Now, Guillermo will introduce our team roles and how we work together.
Thank you, Nicholas. I'm Guillermo, and our team organized itself this way. Abrar served as our product manager and kept us aligned and safe with the deadlines. And Nicholas handled complex research and problem solving in the projects. I focused on managing tasks and keeping writing consistent overall. Andrew contributed on strong research skills and worked on visuals. And then finally, Daniel helped coordinate and maintain our workflow. This balanced structure helped us to stay efficient and effective throughout the entire project. But of course, every team faces their ups and downs. And one challenge that we faced was splitting the work on the deliverables and make sure the work is done on time. This agreement helped us find a way. Well, yeah, once we had to organize ourselves and we came to an agreement and we found a way to overcome the situation. And instead of letting escalate, we had to emphasize our teamwork overall. And we discussed the issue calmly and made decisions based on what supported the project. Next, Nicholas will explain how we selected our final research topics.
All right, so at the start, each team member proposed a different marine engineering problem. And of these, we considered ship propulsion systems, oil spill predictions, maintenance of aging structures, and sustainable ship designs. After discussing each one, we chose corrosion prevention because it was the most visible in the locations that we visited, and it had very strong ties into chemistry and engineering. Now, Andrew will walk you through what we observed.
Thank you, Nicholas. I'm Andrew, and this is a map that highlights the sites we visited on our boat trip. We went around Pelican Island to Texas City Channel, Gulf Copper Shipyard, the Royal Caribbean Cruise Terminal, and the SS Elma. These areas showed us a range of issues involving corrosion, from aging concrete holes to rusting steel structures. Here's a closer look at the locations, at their specific locations. This is the zoomed in pictures, and we used the GPS coordinates to find them on the map. And these just show the exact locations where we visited. Next, Daniel will explain the first major sites we visited.
Thanks, Andrew. I'm Daniel, and our first site was the Gulf Copper, which is a large ship repair yard. Ships can be lifted out of the water here, which lets engineers inspect the entire hull. We could clearly see the rust, the pitting, and metal loss caused by long-term saltwater exposure. like this site shows why ongoing maintenance is essential for preventing failures in older vessels. And next is the Royal Caribbean Cruise Terminal. This is the Royal Caribbean Cruise Terminal dock, where thousands of passengers board and depart. Because of the weight of the ship and constant movement, the dock must remain structurally sound at all times. Civil engineers designed the walkways and the gangways to handle the stress and corrosion. Prevention keeps the load-bearing supports pretty strong. Abrar will now introduce us to one of the most unique structures we saw, the SS Selma.
Thanks, Daniel. The SS Selma is a 100-year-old concrete ship used by the U.S. Navy. Even with severe outer damage, parts of the ship remain intact because the concrete protected the reinforcing steel bars inside. This shows how material choice, not just coating, can dramatically change corrosion resistance. It also suggests opportunities for future designs using advanced materials or hybrid structures. Now let's look at the man-made waterways we observed. This is a Pelican Island cut, a man-made channel that allows boats to bypass natural obstacles. Engineers must constantly maintain the cut to prevent it filling in with sediment. It's actually called a dink. Yeah, there's a whole process for that. They also install erosion control features to keep banks stable. The site demonstrates how hydraulics and civil engineering help maintain navigable waterways. So Daniel will now talk about the Texas City CHEM.
The Texas City Channel connects the Gulf to the port of Texas City, which allows a passage for large cargo and cruise ships. Engineers here, they perform hydraulic dredging to remove sediment and avoid dangerous shallows. Without this process of dredging, vessels could run aground or damage their hulls. Nicholas will now present our scientific research.
Right, so basically, what our research shows is how significant corrosion is worldwide. It is estimated that about 5 metric tons of steel corrode every single day, and 40% of all steel production goes towards replacing corroded parts. 60% of the offshore fleet is already past its design age as well, which increases maintenance demands. And corrosion rates range from 0.1 to 0.3 millimeters per year to as high as 2 to 4 millimeters per year in contaminated seawater. Waves also strip protective oxide layers, exposing fresh metal to corrosion. And now Guillermo will continue to the scientific solutions.
All right, thank you, Nicholas. So we have three main ways to approach these corrosions using chemical engineering, material science, and civil/marine engineering. So in chemical engineering, chemical engineers study the electrochemical reactions in corrosion, and in material science, they develop coatings like epoxies, silicates, metal, certain types of metals, and smart self-healing coatings for the ships, so that it makes corrosion harder to occur. And in civil/marine engineering, they inspect structures, designs maintenance cycles, and use remote monitoring for offshore environments. The main idea to our solution combines advanced coatings with sensor-based corrosion monitoring, especially in high-risk zones near the waterline and splash zone. And now Andrew will wrap up with our references.
Thank you, Guillermo. Here are the key references that we use for research. These includes work from Marco, Valdezia, Brodeur, and Alibori. These sources provide scientific data on corrosion rates, material analysis, and engineering solutions that supported our project. Now we'll close with our presentation.
Thank you for watching our presentation.
Yeah, we hope it helped explain the importance of corrosion prevention.
To emphasize, our boat trip gave us real world examples of these engineering challenges, and that really helped.
And our research showed how chemistry, materials, and engineering connect.
Thanks again for your time. We appreciate it. Thank you.
Thank you.